Hi guys, today we are going to be covering some of the basics of algebra. So let's start off. What is algebra? Algebra is the part of maths where we start to introduce letters into math, right? So I'm sure you all know we have something like 2x or 3x, right? But what do these x's or these variables mean? So x is essentially just a placeholder. If I gave you the equation 2 plus a question mark, and I told you that that equaled 6, and then I asked you to find out what is that missing value? What is that question mark? Right? I'm sure you would all tell me that that question mark would equal 4. Right. And for the same thing, if I had told you that 2 times something was 8, you would all know that that something was 4. Now in maths, we don't like to use question marks. Instead, we use letters. So we can rewrite the above expression, which was 2 plus question mark equals 6, as 2 plus x equals 6. And from there, we would need to solve for x. And as I'm sure you all know, x is therefore 4. Similarly, if I were to give you that 3x equals 9, I'm sure that you could all tell me that that means we have 3 times x, and that gives us 9, right? So 3 times what gives us 9? I'm sure most of you would know that 3 times 3 equals 9. Okay, and that means that x equals 3 because this was our missing number. So now we have shown that a variable such as x or y or any other letter of the alphabet is essentially just a placeholder. We don't necessarily know what the value is yet, but we can maybe figure it out later, depending on what the question asks of us. So now I would like to discuss the idea of like terms. So in math, if I were to give you the sum 3 plus 4, you know that that would be 7. But now what would happen if I gave you 3a plus 4a? That would be 7a. Think of it like this. If I had 3 apples and then I got 4 more apples, in total I would have 7 apples. Right. And we notice that here we've got an A and here we've got an A. That means that 3a and 4a are like terms because they have the same variables. So with that in mind, let's have a look at the next example. Here we've got 3a plus 3b. As we can see, these two terms do not have the same variables. The first term has a variable a. The second term has the variable b. Therefore, we are unable to add these two terms together, and this expression is in its simplest form. Now let's have a look at this expression, 5x plus 7. As you should be able to see, we've got two different terms over here. 5x is a term and 7 is a term. Remember, a term is something that is separated by a plus or a minus sign. As we can see, there is a plus sign over here, meaning that the 5x is separate to the 7. So those are two separate terms. Now let's look at each component of this expression. So we start off by having a look at the 7, and we see that there's no variable associated with the 7. And that means that our 7 is called a constant. If we have a look at the first term, the 5x, we see that in red we've got the letter X. And as we discussed earlier, this is called a variable. Lastly, we have the 5, which is in front of the X, and that is called our coefficient. It is a constant which we multiply our variable by. Now I have written down 4 variable terms over here. For each of these, we can identify both the variable as well as the coefficient. So for this first one, we see that our coefficient is 2 and our variable is x. For the second one, our coefficient is 3 and our variable is once again x. For our third one, our coefficient is 7 and here our variable is y. And lastly, for the fourth one, our coefficient is x and our variable is z. Alright, so now let's have a look at some examples. Question 1 asks us to identify the number of terms which are in this expression. So remember earlier on I said that terms are separated by plus and minus signs. So if we have a look at this one, for example, we see that we've got a plus sign over here and a minus sign over here. That means that we are left with a term over here, 6x, another term over here, 3y, and finally we have the term 2z. So our answer for this question would be there are 3 terms. Question 2 once again asks us to identify the number of terms in this expression. And as I said previously, terms are separated by pluses and minuses. So this means that we have a term over here, and over here. So that means that our answer is 3 terms. I understand that for this example in particular, there is a plus in the brackets over here. Because this plus is within the brackets, it does not separate terms. We still regard this entire piece over here as one term. For question 3, we are asked to find the coefficient of a. So we are given this expression and we are told that our variable is a, right? And remember, I told you that the coefficient is the constant or the number that is being multiplied by our variable. And over here we can see that the number 2 is being multiplied by our variable. Therefore, our coefficient is 2. Next, we have question 4, and we are asked to multiply a by b times b. So now we need to think back to our rules about exponents. When we are multiplying like bases, we add exponents. So for example, when we multiply a by a, we know that both of these variables have an invisible 1 at the top, right? So that means that when we multiply them together, because they are the same base, we keep the base and we add the exponents. And we know that 1 plus 1 gives us 2. And that is how we know that a times a is a squared. We can apply the same rule for b times b, where we've got b times b will simply be b squared. Right, now, since we know that a times a is a squared and b times b is b squared, we've got that a times b will be a squared times b squared. And that is our final answer for question 4. Question 5. We are asked to simplify the following expression. Now remember the rules of BODMAS, where the B stands for brackets, the O stands for of, the D stands for divide, M stands for multiply, A stands for addition, and S stands for subtraction. So this means that we need to work with our brackets first. This means that we are going to perform all the operations inside the brackets first before we carry on with anything else. And inside our brackets, we can see that we have got 2y times 2y. So when we multiply variable terms by each other, we start by multiplying the coefficients by each other. So we get that 2 times 2 is 4, right? 2 and 2 gives us the 4. And then we multiply the y's by each other. And remember, just like for the previous example, where we had a times a giving us a squared, we now have y times y giving us y squared. So remember, 2 times 2 gave us 4, and the y times y gave us y squared. So this means that inside our brackets, we now have 4y squared. So we can rewrite this expression in its simplified form as 3 times 4y squared. And now, since we have completed everything inside of the brackets, we can now multiply the 3 into the brackets. So we can then multiply the 3 by the 4 to get 12, and there are no more variables to be multiplied, so we simply carry down the y squared. Remember, we can only multiply coefficients by each other, right? We can only multiply numbers by numbers, and we can only multiply similar variables by similar variables. If I had given you, for example, y times x, we can multiply these two by each other, but it's not going to give us y squared or x squared. It is simply going to give us x, y. So just to bring it back, our final answer for question 5 was 12y squared. For question 6, we are asked to add up each of these terms. And as we can see, each term has the same variable being the letter a, meaning that we can add up these terms without there being a problem. So to start off, remember that there is actually a little invisible 1 in front of the a. It's the same as saying one apple or an apple. Instead of saying I have one apple, I say I have an apple, which is why we don't write the 1 in front of the variable when we only have 1. Okay, so to do this, we need to add up each of the coefficients. So we're adding 1a with 5a with 3a. So if we add 1 plus 5 plus 3, we get 9. And remember, if I have 1 apple plus 5 apples plus 3 apples, it's 9 apples. We cannot forget to include the variable at the end. So our final answer for number 6 is 9a. For question 7, we are asked to simplify the following expression. To do that, remember that when we add or subtract, we can only do so with like terms. So firstly, how many terms do we have? Well, we see that we've got a minus sign over here, a plus sign over here, and another minus sign over here. And that means that this is a term, this is a term, that is a term, and that is a term. So we have 4 different terms. Once we have identified all of our terms, we need to identify which of them are like terms. Remember, like terms means terms which have the same variable. Now let's have a look at our first term, 10. We can see that 10 does not have any variable associated with it, so we call that a constant. If we have a look at the rest of our terms, we can see that we don't have any more constants. Therefore, our term 10 cannot be added or subtracted to any of the other terms, and we leave him alone for now. Next, we have a look at our next term, minus x. As we can see, the only variable here is x. And if we have a look at our other terms, there are no other terms which have only the variable x. So just like with our term 10, we cannot let x interact with any of our other terms. Next, we have plus 5xy. And for this term, our variables are x and y. And if we have a look at all the other terms that we've got, we can see that we do in fact have another term which has the exact same variables, and that is minus 3xy. So we can see that the term plus 5xy and the term minus 3xy are in fact able to interact with each other because they have the same variables. Remember, with those variables being xy, right? So that means that they can interact with each other. So for our final answer, because 10 does not interact with any of the other terms, we just drop it to the next line. Minus x does not interact with any of our terms, so we drop that. However, 5xy and minus 3xy do interact with each other. So remember, when we're adding or subtracting, we first have a look at our coefficient. So 5 minus 3 is plus 2. And then remember, when we have 5 apples and we take away 3 apples, we are left with 2 apples. In this case, instead of apples, we have xy. So we had 5xy minus 3xy, so we're going to be left with 2xy. Remember, whenever we add or we subtract, our variables stay the same. It is only the constants which change, and we can only let like terms interact with each other. We can only add and subtract like terms. For question 8, we are given the expression 3ab plus c. And we are told that a equals 5, b equals 2, and c equals 3. And we are told to simplify that. Right, so next, what we need to do is we need to substitute in each of these values. Remember earlier on, I said that variables are just placeholders, right? They can take on a value, but we don't always know what that value is. For this question, they are telling us what each of those values are. So we are going to need to substitute in those values and then get our answer. So instead of my variables, I have written brackets, because what we're going to be doing is we are going to be substituting in values for each of those variables. So for the variable a, we were told that a equaled 5. For b, we were told that it equaled 2. And for c, we were told that that equaled 3. So now we have something easy that we can work out ourselves, or if we're lazy, we can type into a calculator. So we have got 3 times 5 times 2 plus 3. And that equals 33. So our final answer for question 8 is 33. A side note, whenever we are substituting in values for our variables, we like to keep them inside brackets so that we know that we've substituted them in, and it makes our calculations later on a lot easier. So please do remember that next time you're going to be substituting in values. So for question 9, we are given the expression 2a plus 2b plus 2c, where a equals 5, b equals 2, and c equals 3. And we are asked to simplify this expression. So we rewrite the expression with brackets instead of our variables, and we can say then 2 times 5, which is the value we substituted in for a, plus 2 times 2, which is the value that we substituted in for b, plus 2 times 3, which is the value we substituted in for c. So we have 2 times 5, which is 10, plus 2 times 2, which is 4, plus 2 times 3, which is 6. And this gives us 20, which is our final answer for question number 9. For our final question, question number 10, we are asked to simplify the following. So remember, previously I told you that when you have brackets, you need to solve everything inside of them first. So if we have a look inside of our brackets, we can see that we've got x plus y plus 3. And remember, I said that we can only add like terms. So if we have a look at the first term, x, we can see that there are no other terms inside of the brackets which have the variable x, so we leave it alone. We then have a look at y, and we see that there are once again no other terms inside of the brackets which have the variable y. Lastly, we have a look at the constant term 3, and we see that there are once again no like terms. So we in fact cannot add any of the terms inside of the brackets. So now we can multiply the 4 into the brackets. To do that, we need to multiply the 4 by the x, then we multiply the 4 by the y, and then we multiply the 4 by the 3. We multiply the 4 into each of the terms. So 4 times x gives us 4x. We then add that to 4 times y, which is 4y. And then lastly, we add that to 4 times 3, which is 12. So our final answer for question number 10 is 4x plus 4y plus 12.